We're asked to find the exact value of the given expression. We have sine of pi divided by 3 times cosine pi divided by 2 plus cosine pi divided by 3 times sine divided by 2. This expression should remind us of the sum of difference identities for sine and cosine shown here below. So if we focus on the right side of these identities, notice the sine of a plus or minus b equals the sine of a times the cosine of b plus or minus the cosine of a times the sine of b, and this does fit the form of our expression where we have a sum. For our expression, notice a is equal to pi divided by 3, and b is equal to pi divided by 2. And because we have a sum, the expression is equal to the sine of the sum of the angles, or in our case, the sum of pi divided by 3 and pi divided by 2. So again, the given expression of sine pi divided by 3 times cosine pi divided by 2 plus cosine of pi divided by 3 times the sine of pi divided by 2 is equal to the sine of the sum of pi divided by 3 and pi divided by 2. The next step is to find the sum of these two angles and then determine the sine function value. Well, we know to add fractions, we must obtain a common denominator. In this case, the least common denominator is the least common multiple of 2 and 3, which is 6. And therefore, we multiply the numerator and denominator of pi over 3 by 2. And we multiply the numerator and denominator of pi over 2 by 3. Notice how this gives us 2 pi divided by 6 plus 3 pi divided by 6, which equals 5 pi divided by 6, or if we want, 5/6 pi radians. So now we know the sine of the sum of pi divided by 3 and pi divided by 2 is equal to the sine of 5 pi divided by 6. And now we need to find the sine function value, which we can do using a reference triangle or the unit circle. We will go ahead and show both. To use a reference triangle, we first sketch 5/6 pi radians in standard position, where the initial side is along the positive x-axis. And then we rotate 5 pi divided by 6 radians counterclockwise, which is 1/6 pi, or pi divided by 6 radians, short of half a rotation, which would be approximately here. So again, this angle here is 5 pi divided by 6 radians, and the reference angle is the angle formed with the terminal side and this negative x-axis, which is pi over 6 radians. And now let's sketch the reference triangle. We should recognize this is a 30, 60, 90 reference triangle, where we can label the short leg 1, the hypotenuse 2, and the longer leg square root 3. However, we are in the second quadrant where x is negative, and therefore the square root 3 is negative. And now we can use this reference triangle to determine the sine function value, where the sine of 5 pi divided by 6 radians is equal to the ratio of the opposite side to the hypotenuse, which we can see is equal to 1 divided by 2, or 1/2. So the exact value of the given expression is equal to 1/2. Let's also find the sine function value on the unit circle. The terminal side of 5 pi divided by 6 radians intersects the unit circle. At this point here on the unit circle, remember sine theta is equal to y, and notice how the y coordinate is equal to 1/2, verifying the sine function value as well as the value for the given expression. I hope you found this helpful.